Hello, dear friends. First of all, I would like to say that I would prefer to be in presence in front of you. Unfortunately, this year is a very different year for all of us. So I'm here by video, trying to give you some message, and let's hope that this is a good thing. I would like first to thanks to Professor Oil El Imrani. I'm hoping to say your name in a good way. I'm sorry if I don't. I never meet you in person, but it was the person that invited me to be here, and I want to congratulate the organization of this conference. And I hope we can meet each other in presence one day, because I would like very much to participate in this conference. I will share my account with you. And regarding the theme of this conference, innovation, qualitative and quantitative research, I believe that I can speak about something that I believe most of you know, and but probably most of you don't like, or at least most of the people don't understand the potentialities of econophysics. And right now, it's probably a very good approach in terms of methodology to study, especially finance and neuronal markets, So the main goal of this communication is to present to you econophysics as an alternative approach for financial analysis. My communication will be divided in two parts. First, I will speak a little bit about econophysics, when it borns, how it grows, what is it? What is this approach? What is this? The usual topics and some examples. And second, I will present to you a study on stock markets, more precisely in frontier stock markets, where we study the weak form of efficiency using some approach from econophysics. And this study, I was a co-author with Isabel Vieira, Wahbia Motti, and Paulo Ferreira. And this is already a published paper. So, econophysics was from the beginning application of principles of physics to financial markets. And the main hypothesis for this application, it was that the assumption that the economic world behaves like a collection of water molecules and that interact with each other. This kind of approach, this kind of phase constitute a way to being possible to apply several type of models and modelization to financial markets and those models that come from physics. But it was exactly this kind of patterns and assumptions that make that the classical economists look to econophysics as something strange or something that does not fit because does not explain the behavior of investors. So it was the first look to this approach was with some doubts, seeing something like this. Well, but the markets are not made by molecules or electrons. They are made by persons. The behavior behind that behavior, there are persons. How can you make the modelization of these markets using patterns from physics? So this started in the midst of the 90s, and it starts especially because of a pragmatical reason. That was that financial markets had so many data. The quantity of available data was so big that it was a kind of attraction to the physicians. At the same way, several physicists that especially worked in statistical mechanics were very unsatisfied with the traditional explanations and approach of the economists, and tried to apply some of the models that were traditional for physics to that kind of data. And the first results were quite impressive. And that's why in the end of 90s, some of the higher banks and financial firms were hiring physicists to analyze data and to make prediction and to analyze the behavior of stock markets and other kind of financial markets. So the term econophysics was coined by a very known person in this area, the father of the econophysics, that is Eugene Stanley. And this name was created in a conference on statistical physics in Kolkata. Right now, he appears in several journals, and not only physics or mathematical journals, but right now it's very common to find papers that use econophysics in finance and economic typical journals. One of the main books of econophysics is this book that I show you here. It's a book from Rosario Mantegna and Eugene Stanley that promote the basis to study the econophysics, how to become an econophysicist, how to learn how to use those traditional physics models to economics and finance. I bring you here some examples in terms of papers. This is a very interesting paper about the history of econophysics past and present. And for the ones that who wants to better understand this is a paper from Physica. And it's very interesting how they present the growing and the way that people start looking and how this way to look at econophysics was changing over time. So right now is a very conceptual and a very well-known approach, or even a discipline, but in the beginning was not. I just bring here, so there are several papers that try to study complexity. Here we have a clusters of traders in financial markets. This is a very interesting paper from last year. Also the power law distributions are very, very studied in this kind of study. This is a very interesting paper in the journal Chaos Solutions and Fractals. The chaos theory is also an approach that is very explored in Econophysics. And I believe this is a very, very interesting paper. Well, this is the paper that I will present. And this paper was published in a traditional economic paper. So it's Journal of Economic Interaction and Coordination. So this kind of approach, it's well received, not only in physics or mathematical journals. This is a very, this type of area is right now an area that you can publish in several types of journals, traditional journals of finance and economics. So in terms of the most usual topics that we can find in terms of econophysics, we have the philosophies of probability, well, the most known about risk management, the maximum entropy approach, or the generalized maximum entropy approach there are lots of good studies about that, and Levy process. The physics of information, we have here the models for group decision making, the complexity, the sociophysics, I'm sorry. In terms of quantitative theory of information, the econometric methods for agent-based models, and the entropy measures for risk, uncertainty, and global dependence. And I will focus in the paper that I will present here in the last topic. So this study, my co-authors were Wahbia Moti, Isabel Vieira, and Paulo Ferreira, is a study about frontier markets. Why do we study frontier markets? So these are, the emerging markets are assumed to be less efficient because they are small, because the volume of transactions are small, because liquidity is smaller. Well, everything here looks small. And everybody starts to think that small markets are not efficient or not so efficient. And sometimes they are simply ignored by investors. And we wanted to study what's happening in these kind of markets. So we focus on frontier markets, that they are characterized by smaller markets, very few traders, and lower trading volumes. And our question is, are these frontier markets weak form efficient? Is the efficient market hypothesis reliable on these kind of markets or no? In terms of the presentation of this study, I will try to give you some idea about the background and the modeling. We use two approaches. We use mutual information that comes from the entropy measures of the information theory. And we use the trended fluctuation analysis, DFA. I will present you in a brief way data and results in some concluding remarks. So about frontier markets, I already give you some idea. These are the smaller and less accessible markets, but they are still investable. They are typically pursued by investors that seeking very high long-run return potential, as well as low correlation with other markets, especially with other big markets like US, Japan, Canada, whatever. We define, or we try to find the definition of frontier markets. And we use the definitions of the Standard & Poor and Morgan Stanley definitions that are, a market turnover, the number of listings, and whether is attracted a minimum amount of foreign investors, and also the the market development prospects. So to find what is a frontier market and which are frontier markets, we follow the Morgan Stanley definition of that. In these frontier markets, they have been focused from some studies. There are not lots of studies about frontier markets, but there are some and very interesting. And they try to analyze also efficiency, but also to try to understand the benefits of the diversification and integration. Mostly found that there is no significant correlation between these markets and the known big markets or the developed markets. And most of the studies conclude about the benefits of using these markets for diversification effects. So frontier economies have been growing in the past few years. So to include these frontier markets in the global portfolio can be good to diversification effects. We want to really understand if there is, if those markets are or not efficient. So we try to not use only a linear approach. We want to use a robust approach. This kind of market, it's a small market, low trading, low volumes. So we want to really let the data speak for itself. So for that purpose, we applied linear models, of course, but we also apply mutual information from information theory to measure the common information between legs, and the DFA to study the behavior of each individual market in terms of long-range dependence. Regarding mutual information comes from entropy. And it measures the common information between two variables. And these two variables may be different legs of the same variable. So according to Granger, Mahasumi, and Racine, a very good dependence measure must have some properties. It must be well defined for both continuous and discrete variables, and must be normalized to zero if the variables are independent, and relies between -1 and 1 for the other cases in order to be easy, the respective interpretation. The absolute value of the measure should be equal to 1 if there is an exact nonlinear relationship between the variable, and it must be similar or at least related to the linear correlation coefficient in order to provide some comparisons to the linear approach. It would be good to be metric, to be a measure of distance and not just a measure of divergence, and must be invariant under continuous and strictly increasing transformations on the variables. So given these properties, and according to several authors, we conclude that mutual information could be a very good approach to measure the global dependence between variables. It does not measure just the linear, but also the global, being linear or non-linear dependence between the variables, having no kind of restriction about the type of relations that there is between the variables. So mutual information will be applied here. This is the global equation for continuous variables to when we have two variables. So it is given by the joint probability times the log of the joint over the multiplication of the marginal probabilities. If the variables are independent, So the mutual information will be new because we have here the logarithm of 1. So this will be new, this part of the equation. And the mutual information will always remain between 0, that is the minimum value that can have, and the minimum between the entropy of each of the variables. If we have here a discrete distribution, but in case of continuous distribution, the maximum value for mutual information is infinite. So we don't, when we have continuous variables, we don't have a maximum. So the interpretation of mutual information as it is difficult. And given this difficulty to make interpretation of mutual information, we need to have some kind of measure that based on mutual information, but give us the possibility to be interpretable. This is to be standardized in some kind of boundaries. We follow the proposal of Granger, Mahasumi, and Racine, and they propose this lambda is the global correlation coefficient that is given here by the mutual information. So it's based on the mutual information between variables. And this global correlation coefficient will be 0 if and only if the variables are totally independent. So in the case that mutual information is new, and will be 1 when there is a perfect relation between the variables, when MI or mutual information as a very high value. So given this, we create entropy-based test, and this test is based on mutual information. We propose this hypothesis. So the null is that the mutual information is null, and the alternative is that the mutual information is positive. The critical values for this test can be found in this paper. They are obtained by Monte Carlo simulation. And we can use now this test using mutual information to test the existence of global dependence. We don't know exactly the type of dependence, but we know if there is any kind of dependence. And after that, we can explore several specific types of dependence between data, between variables, between lags. Well, in terms of the estimation of mutual information, there are several possibilities. We can use parametric estimation or kernel or histogram-based. We don't want to assume any kind of theoretical probability distribution. So we opt for the histogram-based estimators. And in this kind of histogram-based estimators, we can opt for equidistant cells or equiprobable cells using marginal equiquantization. So we used the second approach that is considered more efficient. And the explanation for this kind of approach can be found in Darbalai and Veja. This is a very good paper to understand this kind of estimation. The DFA, the trended fluctuation analysis, it was introduced by Peng in '94. And in the beginning, this method was used to analyze the DNA behavior, but it was very fast, the adoption of this concept to finance analysis, because it has the capacity to detect the long-range dependence in non-stationary data, so in the typical spurious regression. And there are several applications to financial markets in the literature. So it's Right now, it's a very well established approach and robust and very easy to implement. There are 5 steps. They are, I just put here, but I will not explain here in detail because they are very well explained in several papers, including ours. The main goal is to estimate this exponent alpha, and this exponent alpha will indicate the level of long-range dependence. So when this alpha is equal to 0.5, we must conclude that we have a random walk. So the level of the autocorrelation function is null, and the series has no memory. If it's greater than 0.5, we have a long-range dependence with persistent behavior. If it's smaller than 0.5, we have long-range dependence, but with anti-persistent behavior. So this alpha will somehow complement the analysis with the mutual information approach that we will use here. In terms of data, we have here 23 frontier markets. The base to identify these markets was the Morgan Stanley and Capital International database, and we download the data from DataStream. We have daily data. We also make the same calculus to Dow Jones, just to use, and it was used just as a proxy and an example of a big market, just for that. In a first way, we use returns, and all the price series were integrated at order 1, but returns were considered stationary, and we use the Clement et al. Because of the presence of structural breaks. So in terms of the data, these are the countries that we study. We have countries, these are the frontier markets identified by Morgan Stanley. We have the number of observations is not equal because we have the beginning date was defined is different for each market. We have markets like Argentina where we have more than 7,000 observations, but we have like here Bangladesh that we have less than 2,000. This is due to the data, the available of data. In the first way, we evaluate the linear autocorrelation. And we found that all the series exhibit linear autocorrelation in a significant way. So what have we done? We also test the presence of clusters of volatility. And we also found using Arch models that all the returns show the presence of clusters, the volatility clusters. So in the first phase, we use the original return series to evaluate mutual information. And in those series, just Jordan, Lebanon, the Bahrain, Morocco, Mauritius, and Bangladesh show no mutual information. So it means that there is some kind of linear autocorrelation, but is in a very small way. So there is no more global dependence in terms of serial dependence in those series. But the remain, they show statistical significance in terms of mutual information. The values here are the global correlation. Why the global correlation? Because it's easier to understand. It lies between 0 and 1. The series that show linear correlation and clusters of volatility, we filter that series using Arch models. And the residuals of those series were used, and we call it filtered series. And for those ones, we apply again mutual information. And from that, just Serbia didn't show global dependence with mutual information. All the remain stock markets, frontier markets, show the existence of global dependence. We must remember that when I'm measuring here mutual information, the linear autocorrelation was filtered and also the volatility cluster. So probably this kind of dependence that is here in the filtered series has some different causes like chaos or another type of nonlinearity. We don't know the type. I will not provide it here in this presentation, but we test for the presence of chaos with Lyapunov exponents. And some of them show that presence of determinist behavior. We also analyzed the mutual information for the first 10 legs, and the normal fast decay, it was, we found it in some markets like Kenya, like Morocco, Nigeria, Tunisia, more or less. But look at Bangladesh. Well, you can say, yeah, the number of observations, it's quite small. Yeah, it's true. So probably because this is a young market and the number of observations are quite small, the analysis is not so fair. Yeah, probably is this, but those are the results. Look at Jordan. Jordan is also here have not a fast decay, on the contrary. So in the leg 5, there is an increase of the global relation, and again in the leg 10, like Kuwait and Oman. In here, this year we have Europe and American indexes. Croatia and Lithuania are the ones that show a behavior not so consistent with the fast decay that is a traditional pattern in the traditional finance or economic analysis. After this, we estimate the DFA for each series. And as you may remember, the reference value is 0.5. So here we can see that there is just one country that do not show any kind of long dependence or long memory. That is Slovenia. We have the highest values are for Bulgaria, Serbia, and Sri Lanka. And the values that show anti-persistent behavior are Argentina, Lebanon, Bahrain, Tunisia, Bangladesh, and Vietnam. So in terms of conclusions, I don't want to take you much more time. I'm so sorry. We try to investigate the weak form efficiency on these frontier markets. And the first conclusion is that there are non-linearity in the data. Returns are non-linear organized. What kind of non-linearity is there? We don't know. We must explore more. But there is, we applied some filters to separate some types of linear and non-linear dependence, like the volatility cluster. And most of the market's results show that time dependence still exists. So there is more than volatility cluster. The DFA results show that frontier markets have globally long-term dependence, which of course is not surprising. We are expecting of this result. This, according to some authors, I have here Beckert, Harvey, and some others, markets that have few investors who do not trade very often, so liquidity is not very high, are expected to show this term of long-term dependence. So probably the fact that we have very low levels of liquidity may be a sign or a cause for that long-term dependence of this kind of markets. And well, in terms of the global results of mutual information and the FA, we can say that Slovenia appears to be the frontier country with global correlation and temporal dependence that is more similar to the ones obtained for developed countries, so more close to the notion of efficient market. The remaining countries, especially Pakistan, Bangladesh, and most the Middle Eastern country, display the stronger evidence of long-term dependence in their series, and which suggests that there is more scope for potential and succeed technical analysis in order to make some prediction of the returns and prices. Our findings, they support some previous studies on developed, emerging, and frontier markets. And we are still working in this because we really want to understand the type of non-linearity there is in this kind of data to make prediction and to better understand the behavior of the markets. So this is my communication. I hope that I may give to you a good image of econophysics. And I hope that can be a very good tool for you to study financial markets, economic systems, and also social systems. I would like again to thanks to Professor Oil El-Imrani, and I really hope that we can meet in presence one day. I would like so much to go to your university. Bye-bye.